Okay. So for those of you that are at home, this is what the notes look like for today. Please make sure that you access those. What we're going to be doing in section 6.1 and what we're spending the next couple of days on is operations on functions. And it's something that we've seen or seen similar to in chapter 5, right? Where we're taking some polynomials depending on the degree and number of terms. And we are going to be adding and subtracting, multiplying and dividing each of those together. So things that we've discussed before, remember with addition and subtraction, we can only combine terms with similar variables and exponents, right? So if it's like x squareds with x squareds, x cubes with x cubes, xy with xy if we're dealing with multiple variables. Multiplication, we can only multiply terms that go together. And when we do that, we add exponents, right? So if I have x times x, that gives me x squared. With division, we can combine terms with similar variables and divide those through, and we subtract exponents. So if it's x cubed divided by x squared, well, then we do x to the third minus 2, which just gives us an x to the first power, right? So kind of trying to remember some of those similar ideas that we've seen before when we were dealing with polynomials back in chapter 5, all right? We can take all of those ideas now and just apply them to functions. And expressions, functions, sometimes they seem like they're the same thing. They're a little bit different. But we'll see here some notation that we're going to use to kind of define all of these operations. All right. When we are adding things together, you'll see the definition they'll show you is f plus g of x. So you have two separate functions, f of x and g of x. You're just adding each of those together. So you see here in this example, if we let f of x be 2x and g of x be negative x plus 5, we'll use those two functions for all of our examples here. All we're doing is adding things together. So we're combining any like terms that we see, similar variables, similar exponents, just like we kind of noted above. Okay. With subtraction, you'll see it a lot of times written as f minus g of x. So all you're doing is taking one function and subtracting it from the other. The one thing that we need to make sure we include with this, though, is that we distribute that negative sign to each term in my second function, right? So if I have f of x minus g of x, I distribute that negative, then combine like terms. That's how we get that 3x minus 5 in that last column. Okay. What's that? Oh, my apologies. For multiplication of f times g of x, same thing as f of x times g of x. So this function's multiplied together separately. You'll see some distribution like you see in the box here. You might see some times where you have to multiply a binomial times a trinomial. So you have to distribute two terms through to each and then combine like terms. So a couple, different variety of questions that you might see with multiplication. You're still just multiplying the functions together. And then division, you'll see it as f of g of x or f divided by g of x, or the same thing as f of x divided by g of x. The one thing that we need to include that you might want to star, highlight, underline, is that the function in your denominator can't equal 0, right? We can't ever divide by 0 in math. So my function can't equal 0 there, which means that when we go through each time that we do a division problem with functions, we want to make sure that we state the restrictions. So essentially what we're going to do is set that denominator equal to 0, as you see there, and then say the x values that it can't be. Okay. And you see that that's kind of the note that's made right here. Another thing to kind of just keep in mind. Okay. Any questions about that quick introduction to what we're going to be doing with these functions? Like I said, a lot of it could be some review of what we did back in chapter 5, with the exception of the division problems where we have to state restrictions. Everybody good? Any questions at all? Okay. So what I plan on doing is just starting with addition and subtraction. I'll go through and kind of just do these top examples. We'll do the bottom examples as a class, and then we'll do the same thing with multiplication and division. And then towards the end, what we'll do is see how that all combines, and we'll have some independent practice to take care of as well. All right. So this first example, we're given f of x is x squared minus 4, and g of x is 2x plus 1. They tell us to find each function, indicate any restrictions. A lot of time restrictions will only come up with division. So just kind of keep that in mind, not to create too much work for yourself, all right? So the first one, f plus g of x, well, I know that that is f of x plus g of x separately. So I'll take each of those functions and add them together. So wherever I see an f of x, I know I'm plugging in x squared minus 4. Wherever I see a g of x, I'm plugging in 2x plus 1. And then all I do with addition is go through and just combine any like terms. So I have an x squared here. There's no other x squared term, so I leave that as is. The next highest exponent I see is x to the first power with the 2x, but there, again, there's nothing I can combine with that. So I can only combine, excuse me, my constant terms. -4 plus 1 gives me -3. So when I add f of x and g of x for this particular example, my answer is x squared plus 2x minus 3. Okay. Any questions about that first example? Do the same thing with subtraction. So I know that f minus g of x is the same thing as f of x minus g of x. So it'll be x squared minus 4 minus, I want to make sure that I include the entire function, the 2x plus 1 or the g of x inside parentheses, right? I'm subtracting one whole function from another whole function. So I'm including that entire quantity inside my parentheses. And this is where that note comes in that I said from before, as you're copying stuff down here, that I'm going to go through and distribute that negative anytime that I subtract, and that's going to change the signs of each of my terms in that second function. Okay, so I make sure to start, I distribute the negative through, and I get x squared minus 4, now minus 2x minus 1. And then I'll go through and combine like terms again. So I'll have x squared minus 2x minus 5 for my final answer, since I couldn't combine anything besides the constant terms. Any questions about part A or B there in that first example? So just going through and understanding how we would add or subtract two functions together.
I have a question.
Yeah, what's up?
So for part B, so whenever it's a negative, you have to put the gx in parentheses and just distribute like that?
Right. So you don't have to necessarily include the, well, yeah, I would include the parentheses because that allows me to see that I'm distributing that negative sign to both terms. All right. So yes, I would put the g of x inside parentheses and then distribute the negative through. You have to do that every time that you subtract. And it's just going to change the sign of each term in your second function.
Now what if it
I think you cut out there. Do you have another question? Okay. Any questions at all? Any other questions about this example? All right. Let's take a look at the second example then. So now they tell me that f of x is x squared plus 5x minus 2 and g of x is 3x minus 2. We want to find the addition and subtraction of each of those functions. So I know that, again, this is f of x plus g of x. And if we plug in those functions, I have x squared plus 5x minus 2 plus 3x minus 2. Because if you put it in parentheses, essentially all you're gonna have to do is drop them anyway, because when you're adding things together, you keep the same sign. So like if I were to put this in parentheses, think about like what you would distribute, it would just be a 1. So if you multiply each of these by 1, you're still gonna get the same thing left over, right? The signs aren't going to change of either of those. The reason that we include parentheses when we subtract is because the sign is going to change each of those terms when we distribute that negative. Good question, though. What happens when I combine like terms here? So what would be my final expression after I combine like terms, Jake? Good. So x squared plus 8x from the 5x and the 3x. And then the -2 minus the 2 is going to give me a -4. So when I add those two functions together, that is what my final answer is. Any questions about that first example there, just adding together? Let's take a look at subtraction. So I have f of x minus g of x. So that's x squared plus 5x minus 2 minus, remember I'm doing subtraction, so I'll put that in parentheses just to signify that I'm going to change the sign of each. So it becomes x squared plus 5x minus 2. And then when I distribute the negative, what would happen to each of those terms there, Jenna? Minus 3x plus a 2. And then when I combine like terms, what would my final answer be? X squared plus 2x. Good. And that's it, right? Notice that the x squared can't combine with anything. 5x minus 3x gives me the 2x. And then the -2 plus the 2 is going to cancel each of those constant terms out. So I have x squared plus 2x as my final solution when I subtract each of those functions together. Okay. Any questions about part A or B there in that second example when we're adding or subtracting functions together? Right. Let's take a look now at multiplication and division of functions. So very similar to what we just did. I'll go through this first example kind of on my own, and then we'll do the second example a little bit more collaboratively and then work from there. Okay. So I have f of x is x squared plus 7x plus 12. G of x is 3x minus 4. Well, notice now I'm dealing with a trinomial. Okay, a trinomial and a binomial. I'm going to be multiplying and dividing those things. We'll see how this kind of differs in the process that we need to take in order to go through this type of problem. Well, I know that's the same thing as f of x times g of x in part A. So I'm going to take x squared plus 7x plus 12, multiply that, excuse me, by 3x minus 4. And hopefully what we see or notice is something that we saw back in chapter 5, where I have to go through and distribute each term in my binomial to each term in my trinomial and then start to combine like terms, right? Another way that you could write this is 3x minus 4 times x squared plus 7x plus 12. If visually that's a little bit easier for you to recognize the distribution process. So you know you have to distribute the 3x to each term, the -4 to each term. And you can do that because multiplication is associative, which means you can do it in any order and it still will give you the same thing. So however you multiply those functions is fine. What I'm going to do now is that distribution process. So if I take 3x times x squared, well, I multiply coefficients normally. That's just 3 times 1, which is 3. When I multiply the variable terms, x times x squared, remember that I'm adding exponents when I multiply the same exponents together, right? So that's how you get the 3x cubed. 3x times 7x, again, coefficients normally, 3 times 7 gives me 21. X times x gives me x squared. And then 3x times 12 is what's going to give me 36x, right? That x just tags along. Any questions about how I found those first three terms? Do the same thing with the -4 of -4 times x squared gives me -4x squared. -4 times 7x gives me -28x. And then -4 times 12 gives me -48. Question. Like if you did it this way instead. So you could do x squared times 3x, x squared times -4. And you can distribute it that way and just do it in that order. And then you would do the 7x times the 3x, 7x times -4. The way that it would be written in the next line would just be a little bit out of order. But you'd still be able to combine like terms the same way if you did it that way instead. Right. The only thing that we've seen so far is the binomial in front. So I thought that might be easier. But if you did it that way, you'd get the same answers, or the same terms, I should say. Okay. Good question. Now I'm going to go through and combine these like terms. So 3x cubed, I don't have another x cubed term. Remember, a strategy I said to use is after you use a term, cancel or cross it out. 21x squared and -4x squared is going to give me 17x squared. 36x minus 28x is going to give me 8x. And then that -48, that constant term just tags along. I can't combine that with anything else. So that is my final answer. Okay. Any questions about that first example there, part A, when I'm multiplying two functions together? Okay. Part B, I have f divided by g of x. Well, that's the same thing as f of x divided by g of x, which I know is x squared plus 7x plus 12 divided by 3x minus 4. With division, what we want to get in the habit of doing is seeing how we could simplify. If we could factor terms to kind of break them down and then cross off similar terms, that might help us. So notice that in the numerator, if I were to factor this normally, I'd have x plus 3 times x plus 4 divided by 3x minus 4. So I broke it down a little bit. Still not really helpful because I can't cross any common terms away. And with division, you'll see that this is pretty much as far as you can simplify things. Okay. So this would be your final answer. But, question? So no, you're not able to do that since they all belong to separate functions. So if they're being combined with addition and subtraction, they're not their own separate terms. If it was just like 7x over 3x, and I wasn't adding or subtracting anything, then I would be able to cross off x's. But because they belong to different pieces of my function there, I can't split it up that way. So yeah, just something to kind of keep in mind. If you do have a function up top and you have a monomial, so one term, like say I had x squared plus 7x plus 12 all over 3x, then you can break each of them up and divide them by 3x. Remember how we said if we just have one thing in our denominator and we're adding in our numerator, we can split it up that way. Then you can kind of go through and divide things and simplify it like that. But because this is a binomial in my denominator, I can't do it. what we have to do from this point, so that's as far as I can simplify, but I have to take my denominator and make sure I find my restrictions. All right. Remember that I said our denominator can never be 0, right? We can't divide by 0. So I'll take the binomial, the 3x minus 4, set it equal to 0 and solve, because that's going to tell me all of the x values that make my denominator 0. Well, to solve, a lot of times it'll just be a 1 or 2 step equation. I'll add 4 to both sides, then divide by 3. I'll get x equals 4/3. So what we need to include with our answer is that x plus 3 times x plus 4 divided by 3x minus 4 is what I get when I divide those functions, so long as x does not equal 4/3. And again, that restriction that we add on gives us the x value that will make my denominator 0, which is what I don't want. So I have to make sure I include that in all of my answers. Question? Yes. So a lot of times there's only going to be restrictions in division. The reason for that is because, okay, the theory behind it is there's domain and range. We talked about domain and range before, right? Domain's all the x values from left to right that you can plug into a function. Okay. If there's a restriction, that means that there's an x value where there is no y value. Okay. So if we were to plug in 4/3, that x value would be undefined, or that y value would be undefined. Okay. And you'll talk about that a little bit more in a later math class, what that looks like graphically and things like that. So what we're doing with restrictions is saying, okay, well, that's a place where I can't divide by 0. That's where there would be an issue in my graph, or an issue in my domain and range. With addition, subtraction, multiplication, division, when I'm just multiplying things together, I'm just plugging in any values, there aren't going to be any restrictions because there is no place where I have to divide by 0. And you'll talk about other method or other restrictions that you could get and discontinuations and things like that, but that's for a later discussion. For right now, yes, the only time that we really need to state restrictions is when we're dividing. Okay. Good question, though. Getting some theory behind what we're doing. Any other questions?
Can you explain how you got x plus 3 and x plus 4? I'm still kind of confused on that part.
So that was just me factoring the numerator. And the reason why I did that was to just see if I can cancel anything out with my denominator and my numerator and simplify. So x squared plus 7x plus 12, two numbers that multiply to give me 12 and add to give me 7. If I factor normally, that's what gives me the x plus 3 and the x plus 4. But then I couldn't cross anything out, so I just left my answer that way. Technically, you could have left your answer like this as well. I just tried to simplify as much as I could. Does that answer your question?
Yeah.
Okay. Any other questions? Okay. Next example, doing the same thing. So just multiplying and dividing two functions together. So given f of x and g of x, f of x is x squared minus 7x plus 2, g of x is x plus 4. All right. Again, dealing with a trinomial and a binomial. I know this is f of x times g of x. When I plug those in, I'll get x squared minus 7x plus 2 times x plus 4. So I have to distribute each term in my binomial to each term in my trinomial. Again, you can write it the opposite way if that's helpful. So x plus 4 times x squared plus 7 or minus 7x, excuse me. Plus 2. When I distribute that x through, what are the first three terms I'm going to get? So after I distribute the x. Jake? Good. X cubed minus 7x squared plus 2x, right? I take that x and distribute it to each term. When I distribute the 4, what are my next three terms going to be after I distribute the 4? Hear from somebody different. So if I multiply each of these terms here by 4, so 4x squared, good, minus 28x plus 8. Good job, Jason. Okay, any questions about how we got any of those terms there? Now I'll go through and combine like terms. Can I combine anything with the x cubed? No. What about the negative 7x squared? Right, so it becomes negative 3x squared when I combine it with that 4x squared. The 2x and the negative 28x is what's going to give me negative 26x, and then I have plus 8 on the end there. So when I multiply those two functions together, this is what I get. Okay. When I divide, I have f of x divided by g of x. I have x squared minus 7x plus 2 divided by x plus 4. Is there any way for me to factor or break down the numerator in it at all? No, right? There's not two numbers that are going to multiply to give me 2 and add to give me negative 7. So this is actually my final answer for division. Like I said, sometimes you won't be able to simplify it any further than what's given to you. But what do I have to include in my answer though? What else do I need to find? The restriction. How would I find the restriction? Good job. So x plus 4 equals 0. Subtract 4 from both sides. And I get x equals negative 4. So what I have to include in my answer is that x cannot equal negative 4, right? Otherwise, my denominator would be 0. Question? Yeah. So if you could break something down, you could cross terms out, and you're left with a 1 inside your denominator. You have an entire numerator and a denominator simplified completely, then that would be your final answer for division, and then there would be no restriction. So essentially, so long as you have a denominator there, you're going to have the restriction. Unless for whatever reason, maybe your function's just a constant term. That's still left in the denominator, but that won't come up as often as you might see a function left over. Okay. Good question though. Any other questions? Okay. What I want to do now is kind of just throw all the ideas together through one example. All right. So I want you to take about 3 or 4 minutes here and go through this example. You're given f of x is 2x, g of x is negative 4x plus 5. And I want you to find the addition of those functions, subtraction, multiplication, and division. All right. And then in 3 or 4 minutes or so, we'll go over that. And then I'll discuss what the homework is and we will wrap up for the day. Okay. So take a couple minutes here, get each of those problems done. We'll go over them, and that'll be it. right? So you could do that, but then it's plus and then it's negative. Essentially what you're doing is distributing positive. But call it like, so the only reason I'm going to do that is negative is because that means that taking that negative actually changes the sign. So that's why it's a little bit different. Subtraction, addition. So that's how you distribute. Good. Everything else is good. The only thing I just want to make sure you write the restriction so it's a simple. So, yeah. So the only time you do that is there's right. Take another minute or two to wrap this up and then we'll go over it. All right. Let's go over each of these. So I have f plus g of x. My functions f of x is 2x, g of x is negative 4x plus 5. All right. So I know this is f of x plus g of x. So 2x plus the negative 4x plus 5. Or you can just say 2x minus 4x plus 5. When we're doing addition, right? A couple people are asking about, well, why do we include parentheses when we're doing the subtraction and not addition? If we were to include parentheses with addition, we would be distributing a positive 1 through. Well, that's not going to change any signs. So I'm not going to include any parentheses and make things confusing. I'm just going to bring the terms down and combine them the way that I see them. So 2x minus 4x plus 5. Well, when I combine like terms, what would my final answer be for adding each of these two functions together? Good job, Emma. So negative 2x plus 5. Good. Any questions about part A? Part B, I'm subtracting, so I have f of x minus g of x. So I have 2x minus, in parentheses, negative 4x plus 5. Right? This is subtraction now, so I do include the parentheses because I have to distribute that negative through. And what happens when I distribute the negative? What should the next line look like? Good. 2x plus the 4x minus the 5. Essentially, what I'm doing is changing the sign of each term in my second function. So then what would my final answer be after I combine like terms? Good. The 6x minus 5. Any questions about part B?
Mrs. Dacus, can you look at the number A, the letter A?
Yeah, you want me to go over? Is that what you said?
Yeah, because like for number A, I got 6x negative 6x plus 5 because I did wait, hold on. I believe I did this wrong.
That's all right. So with addition, you don't have to include any parentheses. You just combine any like terms. So I have positive 2x minus 4x. That's what gives me the negative 2x. Maybe it was just an error in addition. And then I can't combine anything with the 5. Obviously, it doesn't have an x attached to it. Okay. Let's go to part C. I have f of x times g of x. Well, that's going to give me 2x times negative 4x plus 5. What do I have to do with that 2x? Distribute it. Good. And when I do that, when I'm multiplying things together, right, I just multiply the coefficients normally. So 2 times negative 4 gives me what? And then the x squared. So when I multiply x times x, I'm adding exponents. What about the 2x times the 5? What does that give me? So positive 10x. And then that's my final answer. I can't combine any like terms from there because they don't have similar exponents. So negative 8x squared plus 10x. Any questions about part C? Okay. Then in part D, dividing through, so I have f of x divided by g of x, which is 2x over negative 4x plus 5. Can I simplify that at all? No, right? So this is my final answer. But what do I need to make sure that I include along with my final answer? Restrictions. What is my restriction for this? Close, positive 5 over 4. So you have negative 4x plus 5 equals 0. Subtract 5 from both sides. So you have negative 4x equals negative 5. And then when you divide that negative 4, notice you have a negative divided by a negative. So that becomes the positive. That's all right, though. Simple mistake. Easy fix. So x equals or cannot equal 5/4, right? That's your restriction to that division problem. Any questions about part D or any of the examples that we did here, anything that we covered in class? Okay. Your homework for tonight is on page 389. You're doing numbers 9, 11, 13, and 15, just 4 problems. It looks very similar to the last example that we just did or that you completed independently. So for each of these, you have 2 functions. You're going to find the addition, subtraction, multiplication, and division of each of those. All right. So you go through, do f of x plus g of x minus g of x times g of x divided by g of x for each of these. You see that 9 and 11 are very similar to the ones that you just did. Not a whole lot of complexity there. 13 and 15 get a little bit more complex with trinomials and higher powers as well. So just be, aware of what you have to do in that situation. Okay. Any questions for me about the assignment? Okay, make sure that you get that done when you come in tomorrow. We will go over that at the beginning of class, and then we'll continue with day 2 of section 6.1, which is on composition of functions. Okay. Other than that, those of you that are at home, enjoy the rest of your day, and I will see you all tomorrow.